Alright, boys and girls, welcome back to the drive-thru. Special shout out to Kevin Kim in here doing work. Alright, let's see. How do I want to explain this to you? There's this theorem that you're going to eventually learn. Whoa. I don't want to do that. And it says, let's see. Okay. It says that the sum of the remote interior angles is equal to the exterior angle of a triangle. Now, you don't know any of what that means, but sometimes the book just kind of gives you these questions to make you think, and you should be able to kind of think about this. What would we call this angle here according to x? We would call it 180 minus x, correct? But what would we call it according to the triangle? We would call it 180 minus y plus z. I hope you guys understand. One, we used a supplement rule to do it, and the other one we used a triangle sum to do it. But those are the same angles, so we know that 180 minus y plus z must equal 180 minus x. So if you do a little math and subtract 180 from both sides, you get minus y plus z equals minus x. Divide each side by -1, and you get y plus z is x. And so I just proved it. The angle on the outside of a triangle, if you extend the line, will always be the same as the sum of the remote interior angles. And you don't really need to know that vocabulary term, but hopefully that little concept makes sense to you. So now, how does that lead to this problem? Well, if this angle x is equal to the sum of these two angles, then I know that x must be greater than 81. Has to be bigger than that angle on the bottom left. However, x has a limit. I mean, we could start by saying x has to be less than 180, but I think we can do better than that. Because this angle right here is already 37. So if I called this right here y, I know that x plus y has to be equal to, let's see, what's 180 minus 37? 143. And I know that y has to be bigger than 0. So that means x has to be less than 143. And there is your restrictions on x. Boom!